Hello everyone, welcome back to Trunova-AI. Today we are going to talk about different design structures, different design architectures of AI agents, and we would also try to understand the basic difference between simple AI models and AI agents. So suddenly now everyone is building AI agents, but most people basically cannot clearly answer one simple question like what's the basic difference between AI model and AI agent. So once you understand this difference, then it will be easy for you to design any architecture based on your requirement. So basically we will try to okay, let's say we have AI models on one side and AI agents on another side. Want to differentiate between them. So the basic difference is that AI model is a self-contained program, right? To perform a specific function. If we are talking about any AI model, we are talking about specific function. So by specific function, I mean like we already know that there are different kind of AI models which we have already built. For example, classification model that can be an AI model, and this is defined for just one specific task. For classification, let's say we pass images of different images of animals, and the core duty of this model is to classify that image into whether it's an image of a cat or a dog or which animal. So this AI model is performing just one task. Similarly, we can have another AI model such as speech recognition, right? So this AI model is responsible for only recognizing the speech, nothing else. So we can define as many AI models as we want. Let's say sentiment classifier, which is another kind of classification model. So basically this program is trained to perform one specific function. That's it. And so these models have no goals, right? This is very important. No initiative and no awareness beyond the current input, beyond the current input. So basically, what is happening here? In AI model, we are just passing one input to the model and we receive an output. That's it. And this model, AI model, has just it has the context awareness of just this input. It has no awareness beyond this input, right? But AI agent is something else. AI agent, by contrast, is an active system. It's an active system. It's not a passive system like AI models, but it's a very active and it uses one or more models. Like AI agent can have one AI model, two AI models, three AI models, and by AI models specifically, I'm talking about LLMs. It can have multiple, many of them. And like it uses like this AI agents are usually autonomous, and they have their own set of memory, goals, and ability to take action. So this AI agent basically operates in a loop, and by loop I mean, let me try to draw a loop here. So the loop is usually between the AI agent usually have a loop, and the loop is usually between observe and then another thing is think and then act and then again observe. So if you see, all the AI agents are working within this loop. So they observe, they think, they act, and then they again observe. So it's like every agent follows the same basic loop. They observe, they think, they act, and basically after the action, they learn from the results, and then they repeat. So that's how it is. And for that, all the all the AI agent is exposed to certain things. These things are memory. I mean, yeah, memory, and then tools, and yeah, basically mostly these two things are available for this AI agent. So they can decide what to do based on their observations of the memory and the results of the tools, and for that they basically use different AI models. So if I would like to give you an analogy, you can think AI models as brain. If AI model is a brain, then AI agent is brain plus hand, because it can think and act as well, both. Now, to give an example of AI agent, let's say you want a system to analyze a speech and summarize the speech, and also give added information about the speaker, right? So you see, this, it has not just one specific goal, but it has more tasks. Like, see what we are doing here. First of all, we are analyzing the speech here, which comes under this speech recognition, right? Then we are summarizing the speech, which is another NLP task, and then we are giving some added information about the speaker. So we are understanding, the agent is understanding who the speaker is, and then it has to find the information about the speaker from the web. So it's a very complex agentic flow, but this agent would be able to perform all of this. So each of the task is dependent on the other task. To summarize the speech, it needs to analyze the speech first. So agent 1 model would be responsible for analyzing the speech. Another AI model will be responsible for understanding the speech and then summarizing the speech. So memory comes into play. The second model will be using the result of the first model, and then once we have the summary, and this AI model will understand who is the speaker, and then it will try to use a web, like for example Google engine, to find more information about the speaker. And that's where it will use a tool, because it has to get the information, get the knowledge from the web. The information about the speaker is not present here, nowhere. The speech, which was the input, didn't contain the information about the speaker. So that's how powerful AI agentic system can be. Okay, now to design different AI agents, we need to understand three main components. One is the model, second one is tools, and third one is instructions. If you understand these three components, then we are good to design any architecture. Okay. So model is basically the brain. For example, LLM. Nowadays, a lot of like most of the agents are built using LLMs as the brain. Tools can be like APIs or any external functions to interact with external environment. And then instructions are something which helps the model to understand, to assist it in decision making, like what to do next, which decision should I make. what should be the behavior of my decision. So all these are within instructions, right? So tools can be external functions, they can be APIs, they can be some other environments, okay? And instructions, as I explained, will be the guiding framework for what the agent should do, right? And how to do. So these things are in instructions. For example, an instruction can be a natural language, right? And maybe a system message, and like examples, like a set of examples. For example, we can write instructions such as if the result of one tool is, let's say, X, then then call tool number 2. If the response of tool number 1 is X, then call tool number 2. If the response of tool number 1 is Y, then call tool number 4. So these kind of rules we can create and put in the instruction set. Okay, now let's try to understand this entire workflow, all the three components using this example. Book me the cheapest flight from Paris to Rome. That's what we want our agent to perform. So it's the task of the brain, like the model. It will first look at this input and understands that, okay, the user wants it to search different flight options, and then the model understands that the departure city is Paris and destination is Rome, right? And then the model also understands a constraint that user wants the cheapest flight, and then it also understands that the user wants the model to take an action to book the flight. So all these things the model understood, right? Departure, destination, constraint, action required. Yeah, okay. And now, without the tools, this model is just like a chatbot. So let's say we provide our model with some tools like API for flight search, API for booking, maybe payment API, something like that. Let's say it has these three APIs. And so what? The model will understand this input. Then the model will call this tool, API for flight search. Then once it has the result from this tool, it will analyze all the prices. Then it understands that it has a constraint. So instructions here will be very important, because we can add in our instruction that always choose the cheapest option, right? Then ask for confirmation before booking, right? So let's say we have these two instructions as well. The model already has all the prices. Will it book directly? No, it will not book, because it has instructions controlling the behavior of the model. So it will basically refer to this, always choose the cheapest option, and then it will choose the cheapest option, and then it will call the another tool for booking and payment, and then it will confirm, Based on this instruction, it will confirm whether I should go ahead for the payment. Yes, user will say yes. Then it will call the third tool, payment API. So this is how this entire thing is integrated. So basically, a model without the instruction, like we have two models and same tasks and same set of tools, but they will perform different. These two agents will perform differently if they have different instructions. Okay, now that we have understood model tools and instructions, there is one more important thing which we need to understand in order to design our agent, and that is memory. So memory is very important when we are building agentic systems. Why? Because in order to behave intelligently across multiple steps, as we saw there are multiple steps involved, all these arrows, the agent must be able to remember what has already happened. Like you see, like it has already searched for all the flights, and it has already confirmed from the user for the booking. Like all these decisions and all the actions, all the steps, the agent needs to remember everything. Otherwise, without memory, everything will be disconnected. The agent will not be able to recall what the user asked earlier, what action it had already taken. So that is why memory becomes very important when we are building agentic systems. So when we are talking about memory, we have usually three types of memories. First is short term. Then we have long term. Then we have the last one is external knowledge, right? So let's quickly look at the differences. So when this agent is interacting with the user, when it's taking decisions, when it is calling tools, it needs to store the information, the queries from the user, the confirmations from the user. So basically, short term stores memory within a session, right? So just for one session, it will store all the memories related to that session. For example, in a multi-turn conversation, agent will remember what the user asked 2 messages ago. It will track follow-up questions and clarifications. So these kind of things like conversations, follow-ups, confirmations, etc. So these are examples of short-term memory. Now, long-term memory, on the other hand, it's across um, multiple sessions, and in long-term memory, we try to store something which will be common in multiple sessions, and which can be used in multiple sessions. For example, if I say I want my agent to behave in a particular way for user 1 and in a different way with user B, so our agent needs to remember the preferences, the nature, the qualities, the taste of the user. So maybe we need to store users preferences, right, or settings, these things. Also, we want to store the outcomes of previous sessions, let's say, because for example, if I'm using an agentic chatbot, and I have already asked the agent to book a hotel for me in Switzerland, right? And let's say after 1 week, or let's say after 2-3 months, I'm using the same agent, and I ask the agent to, can you book that hotel again which you booked for me 2 months back? So the agent needs to remember what it booked for me two months back. So that's why Notes about past decisions and outcomes can also be stored. So yeah, these are like historical, um, like we can also call it historical outcome, historical tasks. So yeah, these are the things which we can usually store in uh, long-term memories. Another very important thing is for maintaining short-term memory, we can maintain that using any in-session context window or some lightweight or some lightweight memory data structures, right? So something like that. Um, but for long-term memory, we need external data bases, right? We cannot store them in a lightweight memory data structures or in session context, but we need explicit storage and retrieval mechanism. So basically, it's often we use databases for long term memory. Yeah, and when we talk about the final category of memory, external knowledge, we have already seen this. This is basically the knowledge base which we build in RAG system, and this can be like anything, like a search knowledge base, um, um, I mean, in like vector databases, which we have already seen in RAG. So these are basically external knowledge memory. So these three types of memories are mostly used in agentic system design.